everyone. Thanks for joining us. This is the IoT show. We're live, and now no one is online, but people will come up, I'm fairly sure. That's the first time we're doing live for the IoT show. I hope you'll enjoy that. If that works, we'll do that again. And we're starting tonight. We are at Embedded World. That's in Austin. That's the first time the event is happening in the US. And we'll see pretty interesting people coming up tonight. We'll see people coming up with their beers, with their drinks, and we'll have a conversation. I have not prepared any specific topic, but I'm sure people like Jason here will have plenty to say. Jason, thanks for coming today. How are you?
I was supposed to talk about something?
Maybe. We have 10, 20 minutes,
Okay.
And we'll try to entertain people there.
We can talk about Texas. This is my home state.
It is, right?
No, I live in Michigan now, but I love Texas still.
You're from here?
Texas barbecue, Tex-Mex.
I have to say, barbecue good. We went to a place with my wife last year. It was that remote restaurant, barbecue restaurant in the middle of nowhere, eating on the wooden table with a paper.
The pickle, the cheese, the onion, that was awesome. Bread, that's the way to awesome. Eat Texas.
So we arrived and we said, "Yeah, we're gonna go with the all you can eat." And the guys looked at us like, "Yeah, we want to try everything." Didn't go so well. But anyways. So tell me a bit about yourself. So for those who don't know you, tell me about who you are and why do you have such a nice T-shirt?
Yeah, my nice little puppy dog eating Raspberry Pi. So I spent almost 30 years at Texas Instruments, and I decided that I'm a product of what happens when you let software people have too much control over hardware.
Yeah.
Right. And so I tried to get people to help me make hardware that was more suitable for my software tastes.
Okay.
Especially running new architectures like ARM initially, and now RISC-V, to run embedded systems, right? So making things into appliances, but always open source.
Okay.
Right. So hardware that's open source hardware to run open source software. And I think that's somewhat why you might see me poke a little bit of fun with the Raspberry Pi folks, because a lot of people don't know that while a Raspberry Pi may run open source software, it is not open source hardware.
Yeah.
Whereas BeagleY-AI is. Yeah. And I think it makes sense to choose an open source hardware platform to run your open source software.
And it's not a new endeavor. You've been doing that for
Beagle. Yeah, I've been doing it so we started in 2008 or so. So what is that? 16 years now. And I know you've been doing some consulting work, right? So I left TI and now I do some of my own consulting work. And so I make with Beagle. I make the open source hardware that I want to use in the projects, right? If whether they're IoT or robotics projects, right? It's the hardware that I want to use in my projects.
Yes. Do you see, from your perspective, you've been doing that for some time. I would say, is it fair to say you're trying to simplify hardware to really focus on adding the value at the software level?
Well,
and make it simpler
to get it to the
hardware.
The right point of abstraction. I won't say like always simplify, but at least get it to a point where you can actually peel back the layers of the onion to start building some understanding, right? The Linux kernel is not the easiest thing to understand, but it is possible to at least understand it from an interface level without too much insanity.
Yeah.
And then you have this Git history log, right? That tells you where did everything come from, right? You can look at Git blame and you could say who did this and why they do this and learn from it, right? So it's for me, it's not always about making everything just easy, right? Because if you want to make everything completely easy, you have to just hide everything away. And it's about making the easy things easy, right?
Yeah.
But the hard things possible, right? So instead of blocking off the ability to go further, right? Right. It may not be easy, but I'm going to try to make sure that there are those tools So if that's like tool chains for supporting the different processor elements within an SoC, right? I want to try to get all of it out, right? So it's we want to make the easy things easy, and Linux can help, but like you want like all the Python libraries and all the other things to kind of make things simple. With the BeagleY-AI, we've got things in a Raspberry Pi 5 form factor, and so like putting it into my Raspberry Pi system is like mechanically and electrically easy. But then you can go further, right? You can run Zephyr on the R5. It's an 800 megahertz core. You can do real-time I/O. You can program the DSPs. Right.
So it's fair to say, because the reason why I was asking this question about democratizing or simplifying is because I'm seeing many players try to really abstract these underlying layers, offer them as simple APIs, and open up embedded development to other types of developers who are not today super familiar with the specificities, I would say, of embedded development.
Absolutely, right? So just think of it as a computer, right? And I think I've been guilty, if anything, of emphasizing embedded too much. I think, right? So it's just a computer, but so many things in our lives are made out of computers. And my hope is that people can build an understanding of how those things are made so that they can take control over those things in their life.
That makes sense.
And like if you want to do that in Python and MicroPython, right, you can get a BeagleY-AI, program it in Python, program the microcontroller, the R5 in MicroPython, right? There's a MicroPython interpreter that you just run on the R5, and you can just do everything in Python. And I think like there's a lot of great learning materials using Jupyter notebooks, doing different things that really make programming easier but with Python. But I'll tell you, it's also one of my least favorite programming languages as well.
Especially when you're coming from this world of C, C++, you have control over everything. Fine control, right?
But I don't have to wonder like how many layers deep did an exception pop up, right? People are pretty decent at documenting. With Python, we leverage Sphinx and the documentation infrastructure for Python a lot, which is really nice. But you find almost nobody documents the exceptions that their modules generate. And so you can just like create a generic capture, and but you can't necessarily like know what sort of things, how many layers deep are going to produce exceptions. That's one of the reasons I don't like Python for like production projects, although I'm guilty of using Python in production projects.
You know what? I'm seeing more of these non-traditional languages, I would say, for embedded development coming in. I'm seeing Rust for good reasons.
Well, Rust makes sense. Rust is...
I'm seeing .NET, Wilderness Labs,
absolutely.
GHI, they're bringing .NET. I'm seeing WebAssembly.
I love
actually we have someone
having LLVM like directly target WebAssembly, right? Means that you can really write WebAssembly in any programming language.
Exactly.
Right. If you want to write WebAssembly in Rust, or you want to write WebAssembly in Ruby, right? I've been playing a lot with the programming language Crystal, which is a LLVM compiled Ruby-like language. I love Julia, which is like a mathematical language, right? So people use R. One of the really common things we see in embedded and stuff that I'm doing is using Docker containers in embedded systems, right? So, or just, like you just treat it like you would the, cloud infrastructure, and, we use DevOps and push out containers.
At him that we're going to have another Jason soon on the Here Live podcast. Jason is working on exactly that, leveraging WebAssembly infrastructure to have a container app model for embedded device. But I will not spoil it. Later.
But it is. I think WebAssembly is really interesting for embedded devices, right? Because you can contain the system, but you can also make something that actually runs very efficient, right? Because you can produce the WebAssembly and then you can JIT it for your target processor.
Exactly.
And so you see a lot of people like with Zephyr, like taking runtimes and taking like stuff that you can deploy at the end, right, and making it run really efficiently.
Yeah, exactly. So tell me, back to BeagleBoard AI. So AI. Everyone has it. and you have it on your shirt, so I have to.
Yeah, I do. I
I
do.
do have to bring it up. Do you think how is it impacting and changing? We were already doing AI, artificial intelligence. We called it differently, but there is generative AI coming. But to me, that's putting spotlight on real AI, or what I would call boring AI.
Yeah.
That is AI used to do something, right?
I don't know. I think it's easy for me. Like I want to check myself when I say that, right? Because I say exactly what you're saying.
Yeah.
Like and like for making like real things, this is some of the least interesting AI.
Yeah.
But it translates to people, right? AI is now like being something that an average person can experience to make their writing better, right? And I do think we're programming is such a like a I think when you look at Star Trek and you see people talking computer and they do this that sort of reality isn't so far off, right? And I say that full well seeing how awful some of the generated code is that comes out of some of these I won't name brand names.
Yeah.
But
you won't say Copilot. You would not say ChatGPT. Don't say it. Don't say it.
So, but it can really generate some junk in code and some dangerous codes.
It's to me the way I explain it to friends and family who are not in computer science or development. I'm telling them it's a tool, and we will have to learn how to use it properly. They will have to have, guardrails built around it. And we will have to specialize models for certain tasks to make them better.
Well, but I think languages, like today's computer programming languages aren't the best targets necessarily for generative AI models, right? And in fact, it's interesting that a computer is better at expressing English or other native languages in a way that's more comprehensible than it is computer code.
Yeah.
And I think that speaks a lot to the state of computer programming languages today. Like I think we need to, as an industry, try to figure out how do we get our hands off the keyboards, but continue to program, right? You look at people doing robotics, right? They don't want to be doing robotics at a keyboard. They want to do robotics in contact with the mechanized arms, the different things that they're working with in their system.
And there's another aspect of generative AI that's going to be interesting is for operators. When we're able to bring these models, not LLMs, but small language models, like optimized for the device and specialized in the, I would say, the literature of this machine, this engine, whatnot, that's going to be super
contextual, right? And a small language model in a contextual environment, I think, can help you actually do real programming, right?
Yeah.
And I think you get into domain-specific languages and things that are much more constrained, rather than trying to have it generate C, C++, right? That are just so wide open that they don't really give you like code that's easily verifiable or actually does what you intend it to do. And I think another one, look at generative AI. I think some of these time series data, right, and like taking a step back from generating language, but just simply predictive sequences, right? I mean, there's obvious applications in finance, stock market monitoring and stuff, but just failure analysis for all of the various hardware that's out there, and much lower compute requirements, right? But I think that there's a lot of opportunity for us to learn from time series data, and that's one of the big applications I see for BeagleY-AI is monitoring time series data and performing local analysis to find anomalies.
Yeah,
and we've had a lot of tools to train models to try to find anomalies offline, but I think a generative AI, right, is one of those things that can help us, kind of bridge the gap of not enough data.
Yeah.
Right. So where it just sees the patterns over time and recognizes it, you know, I don't want to say like a person, but like a person.
Yeah. That complex data becomes explained and organized.
Yeah. And they can find patterns.
Before I let you go.
Uh-oh.
Oh, yeah, you're going to have to.
Did I say BeagleY-AI enough times?
Yeah,
because pi is irrational.
But I want you brought some hardware. Not sure the battery is recharged enough.
Okay.
But you brought some toys.
I did.
Toys.
My fingers.
I'd like for you to tell me in a few minutes, what is it that you're excited about? How would you say BeagleY-AI many times? The question is, what is it?
So this is BeagleY-AI. So it is a single board computer. So it's just a computer. You can plug in keyboard, monitor, and mouse, and you just use it like a desktop computer. But you can also use all of its fun little interfaces and capabilities to put into inventive projects.
Okay.
So this is my mustache camera, which I can't even just like reach the switch. I need to get my, it'll take me a second to go get to try to flip the switch. But this is using computer vision. So I've got a little USB camera here, and then I've got a DSi display, and then the BeagleY-AI. And this looks for faces and puts mustaches on them.
That's fun.
And then if you use the clicker, it'll upload them to Imager to share them with the world, because everybody wants to see your mustachioed face.
It's awesome. I've seen these students from Harvard, I think, who have been streaming image from one of these like smart glasses up to Instagram, and they used algorithms in the cloud to recognize people, bring data from the people, re-inject that into an app that could read, so they would recognize people in the streets and tell them, hey, are you blah doing this and working for that?
Yeah.
And people say, who are you? This is a
very intrusive way that people know that you're invading their privacy, and that we can display the status.
That's funny, but I also think that it illustrates how you can bring AI at the edge, containing in a device like that, for doing something here funny, but could become something related to safety, related to interesting scenarios.
It's a prototype for something that'd be an interesting scenario. But so you can kind of work this as a software starting point and kind of an infrastructure for doing something.
And it's on a heavy lanyard for events as well.
and leveraging the Pi compatibility, the battery is stuck up underneath here, right? So this is using just an off-the-shelf Pi UPS with batteries in order to run, right? So having that common form factor lets you build things really quickly.
Awesome. Jason, thanks a lot for your time.
Oliver, nice chatting again.